Now that we've picked out some key features, our final part today is how to actually write the exponential function. So the parent function for an exponential is a times b raised to the power of x, where you'll notice that a is the initial amount, which is aka our starting amount. We're used to seeing that. And b is our constant ratio. So that's when we take our two values and divide them and get the same thing every time. So let's start by looking at our table. So the initial value, we know that another way to say that is our y-intercept, okay, or its starting amount. So when x equals 0, what does y equal? And our table actually happens to tell us that. It says right here that it's 81. So that's our initial value. Now we need to find the constant ratio. So we're looking for how we get from here to here. So if I take 54 divided by 81, that comes out to be a repeating decimal. So let's leave it as a reduced fraction, which would be 2/3. As I go from 54 to 36, 36 divided by 54, that'll reduce to a fraction of 2/3. And check it 3 times to make sure that we have a pattern. 24 divided by 36, again, will reduce to 2/3. So we know that our a value is going to equal 81. That's our initial value where it starts when x is equal to 0. And we know that our b value, our constant ratio, is equal to 2/3. So therefore our function, our f of x, is equal to 81 times 2/3 raised to the power of x. There's our function to match our table. Now let's take a look when it's on a graph. Same thing's going to hold true, but we need to come up with our series of ordered pairs so we can help find our values. So let's start with our initial value, which is when x is 0. And we can see right here that a is going to equal 128. That's our starting amount. Now we need to find our common ratio, or our rate of change. So if we take a look at our y values going down, let's see how we get from one to the next. So if we take 64, because we always take the next one divided by the previous one, divided by 128, we get 1/2. If we take 64 divided by 32, we get 1/2. If we take 32 divided by 8, we get 1/4, but in that case, if you notice, it's skipping by 2 values. It overlooked the third value. So we want to go in sequence. So our common ratio here is in fact 1/2, so our b value is 1/2. So now let's put that together and fill in our function form. So our function of x is equal to our initial amount of 128 times our common ratio, which is 1/2, raised to the power of x. Great job, folks.